Did I go ahead and start recording? Okay, great. So, in housekeeping, remember we try to keep these within an hour time frame. It's very difficult to absorb more than that at one time. I'll try to have the recordings available for you within 24 hours, usually less than that. And again, these are the two links. The YouTube one is probably the first one that I would go to make sure that you get it in a timely fashion. I'm using version 29 on a Mac computer. So you may have a different version. You may be using a PC. So some things may look a little bit different than what you'll see on my screen here as we're working through it. But again, it's just would be some minor changes. You just have to figure out where the extra click is or where the extra icon is, but the same conceptualization will always be there. Again, keep your lines muted. Let's be courteous to others. I'm a one-man shop here, so I'm trying to do a lot and get through a lot of documents and give you a lot of stuff. So it would be very helpful if you do have any questions to put them in the Q&A thread. That way I can focus on one place for questions and not overlook anything that you may have put into the chat. So that would be very helpful to me, okay? And so we always make sure that this is a very safe, friendly, I like to say funny, non-intimidating learning experience where we seek to ease that anxiety, okay? And not a general statistics seminar, meaning questions and things may come up, of course, but a lot of those may be outside of the scope of what we can do here and what we can discuss, maybe getting outside of the scope of the topic. I'll just briefly mention that. And if it really is a question that needs to be answered, you'll always know how to reach out to me to get an answer to a question. But let's keep the appropriate questions in the appropriate place, okay? But we'll make sure that we get answers no matter what you may have. So this is the slide that I always show and I love. We're trying to go from the character here over to the character here, easing the anxiety, okay? And in doing so, when we ease that anxiety, our minds have a lot less cognitive, more energy to focus on the task in hand. And when we see things we're kind of familiar with it and it's not thrown at us and it's shocking to us, we seem to somehow be able to absorb it a little bit better. And this has always been my philosophy ever since I've been teaching statistics. So this is what I kind of do here voluntarily to supplement, your research courses. But anyway, when we talk about the scales of measurement, we know just how important that is, that each variable or data point that you have has to be identified with a certain scale of measurement. And we know that the nominal scale, again, is that categorical variable where we can compare males and females, or high category to a low category, or yes response and no response, etc. Whatever category you come up with, it would be nominal data. We go down to ordinal, where we all have probably answered a Likert scale where someone has asked us our satisfaction about something, a product or a service, and from 1 to 5 or whatever. And that's that ranking order. It's not really equal distances. We don't know how much truly 1 is, then 2 is, then 2 is to 3, etc. because it's subjective rating. You're saying I'm somewhat satisfied, but what does somewhat mean to you? So they differ. And mathematics have to go into place to account for these uncertainties. And so that's why it's important to understand scales of measurement, because certain tests are designed to address matters such as us not quite understanding the equal distances. Then we get a little bit more sharper in terms of understanding. We get equal distances here. But the thing about the interval scale is that there's no true zero value. Now, what do we mean by that? A great example would be if you were measuring weight. We know that if we have 0 degrees, that doesn't mean we have no temperature or no weather. We know it's cold. So there's no such thing as a true zero, meaning no existence of weather. Then we finally get to the highest order is the ratio. And that's where we have equal distances plus a true zero value. And so, for example, and you'll see we'll use the example tonight, is that true zero value being a GPA score, going from 0 to whatever it can go to. Now, again, just to reacquaint ourselves, when we look into SPSS and we're in the variable view, we'll click and we'll note that we can only, assign a scale, an ordinal, or nominal. But you'll just say, well, in the last slide, you just said there were 4 scales. Well, it is, but the scale response will represent both the interval and the ratio. Okay, so if you have an interval or a ratio scale variable, you would select scale, and then the other 2 are there. Now let's talk about this t-test. What is it? Why do we use it? What is it used for, etc.? Okay, give me just a second. Okay, now, the first thing is we're going to look at a scenario. And this is the scenario, one of the 3 scenarios that you're faced with in the week that you're going to be addressing the t-test, the 3 different types of t-test. But in this one, again, we're measuring perceptions about the current level of democracy. So we know this is the variable, this is what we're measuring, and we're going to get a numerical value of this from every person. We know this, okay? But what we want to know is that whatever this value is, we want to know if they differ between North Africa and South Africa participants in the study. So those are the 2 groups that we are comparing on their levels of democracy. So what we would actually be looking at South Africa's level of democracy and North Africa's level of democracy and comparing those. Or for example, we could compare gender, male and females, on, say, the average GPA score to see if males have statistically higher GPA scores than females. So again, you can understand that this is a scenario and it's appropriate for the independent samples t-test. Now, let's look at it. What again does it do? When you read the scenario, you'll see that it's asking you to compare 2 groups. And in this case, those 2 groups would be the group of individuals from South Africa and the group from North Africa. But we're going to compare them on some mean score or the average score from those 2 groups. And that's what we call the dependent variable. So what you need for this test is a variable that's categorical. And now in terms of scales of measurement, we mean nominal. This is the nominal scale of measurement. And remember that nominal is the grouping variable. So for example, gender. And we're going to compare males and females. So again, you can see it's very, very important to be able to go into that data set and look into that measure column and understand what you're looking at. And we'll do that again here for this test. Now I've got my 2 categories, but what am I comparing them on? That can be anything under the sun in terms of research. The categories can be anything under the sun. But in this example, we're looking at the GPA scores. So basically, a research question for this could be simply if there's statistically significant difference in the average GPA between males and females. In your case, it would be is there statistically significance, perception of democracy between North Africa and South Africa. That's what you would be substituting. Okay, so again, if we go back to the scenario, remember Southern Africa and Northern Africa. And then again, this is what we're comparing. So this is how this information would look in a research question format. So that's what I'm trying to show you, okay? Now, this differs from a repeated measures test is because we only had repeated measures, which we had South Africa, and then we would be measuring South Africa 1 time on something, remember time 1, but then measuring South Africa again at time 2. That's the repeated measures or the paired measures. Now we're not comparing South Africa this year against South Africa 5 years down the line. We're comparing two independent groups, South Africa and North Africa. That's the main difference, okay? Now, and it tells you what data set to use. And then again, this paragraph that furnishes an answer to the question. And we know what the question looks like now. And again, this is how we would take this scenario and turn that into a question. And we'll see that in the exemplar, okay? And then we talk on the relevant statistics, the meaningfulness, and we'll talk about all of that here very shortly. So is everybody okay up to this point? This time we have two different groups or independent groups. And I always say, take a look at the word here of the test. It's called independent, and it's samples. So we know we have two samples, but they are independent of each other. This can't be the same person, and then I'm asking them something later. But look at the word last night, repeated measures. That means I'm going to repeat the measurement from the same individual. I'm not repeating measurements here. I'm only taking one measurement from an individual, be it male or female, and I want to know what your GPA is. There's only one measure, and it's two independent groups, where last night I may want to see your GPA before the term is over with, but I want the same person, I want to see your GPA after the term. So those are paired or dependent samples. They're dependent upon each other. That's the conceptualization that you want to understand. So again, this is what we're measuring, and we're comparing the South and the North. Everybody okay? Of how you would take that scenario and turn that into a question. And again, we're looking at the question here. And again, this is just one format to ask that question. And of course, you just have the corresponding null, meaning no difference, and the alternative, there is a difference. And that's how going from that scenario to a question can be presented. Now, remember we said we have to talk about data assumptions, okay? We hope that we get pretty data and that it's normal and there's no outliers and all those things, but that's just mathematics, and I call it laboratory science, what the mathematician or the statistician would be concerned with. But when we go out into the real world and start collecting data, the data doesn't look like it did in the laboratory when it was being tested to come up with these tests. So, but what the mathematicians that developed the formulas, of course, they say that this is a test for an interval or ratio scale of measurement. So that's not something that you have to test, but that's more of a design issue. You just make sure that you know what you are testing is an interval or scale ratio data. And of course, that the data are independent, meaning that you have two groups, they're independent of each other. The female's response doesn't have anything to do with the male's response. They are independent of each other. So again, this is just design issues. But now we know that we have to test certain things in SPSS, and we'll discuss those now. We know one of the most common assumptions is that we don't want to have extreme or extensive or a lot of outliers. Now, it doesn't mean one or two here, but that discussion is beyond the scope of this lesson. We also talk about normal distribution, right? But again, for each category. So the GPA score for the males needs to be normally distributed, and the one for the females need to be normally distributed. So we have to assess normality. Then we have something called equal variances. And we talked about variances back in the descriptive statistics week. But anyway, each group should have each equal variances. And these are the things, the three tests that we would have to run in SPSS for this particular statistical test. Okay, so again, outliers, normality, and equivariances is what we're concerned with. Now, how would we assess that? Believe it or not, we do it the exact same way we did it for the one sample test and the paired samples test. And that was using the analyze, descriptive statistics, and the explore procedure. I'll give you just a second to look at that. So remember, we'll follow the numbers 1, 2, and 3. When we get to the explorer, remember up here would be the explorer. Just keep factor levels together and then tell it to give you the normality plots with tests. This is going to test the normality for us. Okay. Now, we hit 5 to continue. And remember, we got the box plots when we were looking at descriptive statistics last night and Monday, which tells us if there's outliers. Anyone recall how we would tell if there's an outlier in this box plot? What would it look like? Remember, we would see little
dot outside the
box. Yes, little dots. And it would have a number, say, for example, 22. And we know the record or case number 22 is an outlier. This may be case number 8. But notice, excuse me, we don't see any of those outliers. So we know that we're good to go. So we simply say we don't see anything. We know we've met that assumption. Normality, remember the Shapiro-Wilk test. And again, remember, focus your eyes on what you're looking at and look at test of normality. So you obviously, this must measure normality. It takes some time to look at it and get very comfortable with saying, okay, test of normality. And I know what I'm looking at there. And this is assessing that assumption that has been stated earlier that is something you must test. And this is exactly what you're doing. You're testing it. Your SPSS is doing all the math, but you know to judge it significance against the 0.05 standard as always. And so with this being less than 0.05, we know there's a significant deviation from normality. So we have violated the assumption of normality, just as we have talked about, the past couple of nights. So very quickly, by running these commands, analyze, descriptive statistics, explore, and again, make sure we have the normality plots with tests selected. We've answered questions of normality and outliers. So we know we failed one, we passed the other. And then we're going to talk about, then what do we do? And we can't get in depth in that, but first thing that we know, we have to always assess any parametric test in terms of its outliers, okay? Now we have one final outlier, which is the equivariances, but that's run differently. And now how that's run is that actually when we run the independent samples t-test. And again, just as we have been doing, remember, it's always the analyze, the comparing means. But remember, we did the one sample the first night. Down here, there's going to be a paired sample or repeated measures that we did last night. For this one, that scenario, you're going to take the independent samples. Remember, 2 independent groups. Now, what that'll do is to ask us what is the test variable. We're comparing GPA. Here is where you would take that level of democracy today, I believe is what the scenario. So right here in the test variable area, of course, you're going to have different data here, but let's go back up to that scenario to make sure, yes, levels of democracy, current levels of democracy. That's what would be sitting in here, current levels of democracy, okay? Everybody good with that? But then remember now we have the groups. We're comparing North Africa and South Africa. And that's where you would be selecting the region, which would be in here, and then that would go in here. Now, let me show you some real important, and I'm gonna skip, and I'm gonna go into SPSS now. If you've been nodding or sleeping, please wake up. This is very important. You see something right here called define groups. After we put the gender variable in here in this case, and we know I'm comparing gender on the GPA scores. We know that. But what SPSS needs to know is it needs for us to define these groups. And when you click on this define groups here, it's going to take you to this dialog box here. Now you have 1 and 2 in here. Why is that 1 and 2? And what does that 1 and 2 mean? And it's important to know what you put in here or what you need to put in here. Now, let me explain why, okay? Now, I'm going to go into SPSS. I'll let that open up. It takes a second. But we'll let that load up. But it's asking you to tell me, SPSS, what are the two groups that you are comparing? And what's happening is in SPSS, in the measure column, which we'll look at, we said it's a nominal variable with two categories, but we had the code say one may be male. I don't know that. And we're going to look in the data set. And that's what I'm going to show you when SPSS open up. And two may be female. Okay. So you have to let it know. Why? Because there could be more than two groups in the data set. And in that data set you're going to be using, there is more than two groups. SPSS may automatically default to 1 and 2. And I believe 1 and 2 is not North and South Africa. I believe 3 and 4. And we'll take a look at that, okay? Just to make sure you understand that. So if I can get SPSS open here, okay. Yeah. Afrobarometer. Okay, now everyone should see an SPSS file, and I believe this is the Afrobarometer. Now you see here in the data set, in the variable view, you'll see here that we have a variable, and the variable that you're going to be using, okay, would be, I believe, country by region. Okay, you're going to find it in the data set. I actually just moved it up here to the top. It was down here somewhere. But let's look at this nominal. Remember we talked about scales of measurement? Nominal meaning it's categorical. Let's see what the categories look like, okay? So let's click here in the values and look at here. Does everybody see that? 1, 2, 3, and 4? There are 4 categories to this, but you are only comparing Southern Africa and North Africa. Does everybody see that? Let me look in the chat and make sure I get some responses here. Does everybody see that? So remember in the slide when it said 1 and 2, what would you be comparing if you just went with the default of 1 and 2? What groups would you be comparing? Would you be doing the right thing for the application? So you have to change it to 3 and 4. Everybody good? So let's do that. So when I came up in here to go analyze, compare means, okay, everybody see where I'm at. And remember the independent sample t-test, just as we looked at in the slide. The test variable that I'm looking at, that you guys will be looking at, is going to be the level of democracy today, the current level of democracy today, which is question 46A, right up here. That's what you're testing. And the grouping variable is the country by region. And we know it's the categorical variable. And then remember the define button? You see what it automatically defaults to? Does everybody see that? Automatically. And what you again would be doing is everyone was correct. You would be comparing West and East Africa. So what you have to do is just simply go in and change it to 3 and 4. Everybody got that? Then you're doing the right application. You're selecting the right two groups, and you'll be able to move on with your analysis. Simple as that. So that's why it's important to understand, the scales of measurement, nominal. And if you know if it's nominal, it's categorical. Okay. So for example, let's see, what else is nominal here? Urban. So I guess they want to know if they live in an urban or rural area. And so that's categorical. And what they have here are 3 categories: urban, rural, and semi-urban. You see that in this example? So depending on what 2 categories you are comparing, if you are comparing the urban and the semi-urban, you would have to change that to 1 and 3. Everybody understand me? I'm just trying to make sure. Okay? All right. So now, fantastic. So again, as you can see, this is the concept we were saying here. So we have to go into the data, but we know now that what we have to do for our application is specifically 3 and 4. And then we're capturing, North and South Africa. A very important concept, okay? Because you'll see the output, it's going to say East and West Africa, and you're going to be like, what's going on? Why, is this not working? And that's because we can only compare 2 groups with the t-test. You see, it says group 1 and group 2. It won't allow you to do more than 2 groups. So if we have more than 2 groups that we've collected data from, we have to tell SPSS what 2 groups. And that's what that application is requiring you to do. Now, let's look at what happens when we get the output. Okay? Group statistics. We know we're comparing GPA is our dependent variable, and we're comparing males and females. We know we had 28 males, we had 33 females. This was the male GPA average, female GPA average. On average, the females had the higher GPA. And this was a slight deep standard deviation, but we don't quite know if that's statistically significant yet. Remember, these are the descriptive statistics. We are describing the data. Now, to determine if it is significant is when we go to the independent samples test. Okay? Now, remember, we said that there was one more assumption, and that was the equality of variances. We need to have equal variances. Well, what you have here kind of separating is an F statistic and also a sig value. Do not confuse this sig value for your independent samples t-test. This is the sig value for your assumption of equality of variances. Does everybody see that? Because you're going to have a sig value over here also. I don't want you to confuse those. Does everybody see that and understand that? I would like to get some confirmation there in the text before I move on. Wherever the chat may be, I've lost it. But anyway, everybody understand that. That's what we want to make sure that we attest that assumption. Now, so what would we say then about the assumption of equality of variances then? Would we say that it's been violated or not? Anyone like to take a stab? Okay, remember, we always in our SIG columns, we are evaluating anything against the 0.05 significance level. Okay, this is greater than 0.05. Anything greater than 0.05 is not significant. Anything less than 0.05. So when we say significance, if it was less than 0.05, we mean it is a significant deviation from equal variances, meaning it would have been violated. So what we're looking for here is less than or equal to 0.05. So we're not violating that assumption, okay? But the point is that remember, and look at it very carefully, you're going to see two areas. I'm going to get all this gobbledygook out of here. But when you look at this, I really want you to look at it in two areas. And the two areas are going to be draw a line, an imaginary line, so that you know you're looking at the test for equal variances in these first two columns. Okay? That's for the equality of variances. Remember when we looked at the data assumptions, let me go back to that slide. Remember the homogeneity of variances? That's the third assumption. Remember this one was the box plot. The box plot. Here we had the Shapiro-Wilk test, and now this is the Levine's test. And that Levine's test is right here, okay? And again, if it's less than 0.05, it's violated. Okay. So in this case, we're good to go. We did not violate that assumption. Remember that divisive line is important because now to determine if there was a statistically significant difference to answer that research question after we've assessed all the assumptions, we look at everything on the right side of that divisive line. And remember, we just basically going to be saying that we're looking at a two-sided test. So was there a statistically significant difference between these two groups? Would you say it was or not? Yes, it was. Because, again, the P was less than 0.05. 0.03 is less than 0.05. Now, the important thing is, because the assumption was not violated, you notice we've got two p-values here. We've got two of everything, two lines. If the assumption was violated, less than 0.05, when we report the results, we report the bottom line, okay? So if this was less than 0.05 up here, when we report the results, we're saying that variances was not equal. We would be reporting the statistics from the second line. Everybody see that? And we're going to talk about how to report that, but that's what we would do. That's the correction you would make. You don't have to make a statistical correction. SPSS has done that for you. Okay? So if this is less than 0.05, we violated the assumption and we'll report the second line. If not, in this case, we're good to go. So what we would report would be the relevant statistics on the first line. Okay? Now, let's talk about that. So we have a statistically significant difference between males and females in terms of GPA. And we know that on average, the males have a lower GPA, and that's statistically significantly different, okay? We also know that the mean difference between the two, the average distance was a negative 0.17. So basically, the male's average difference was 0.17 from the females, basically the mean difference, average difference, okay? Now, then when we start talking about the average differences, remember, we always must report the the confidence intervals over here, okay? And so on the lower end, we're saying it would be here. So going this way, we would say on the lower end, it would be here. And on the higher end, it would be here. Again, so we report the mean difference. And we'll see here in just a second that we report the degrees of freedom like we did last night. We report the T statistic. So let's tie that all together now, and let's see what it looks like, okay? So now this is what the narrative should look like. Remember last night we said a repeated measures t-test, but tonight a two-tailed independent samples t-test. And again, we state what we did it for. Remember, we were looking for that GPA gender difference. And we state the independent variable was gender. Okay, you had the two categories, which were male and female. Okay. The reported GPA was the dependent variable. Remember that scale dependent variable. The preliminary analysis are always the assumptions. And remember, we look at normality, we look at outliers, and the equality of the variances. And we know that we always can look at normality by the Shapiro-Wilk test, the outliers with the box plot, and this is the Wien's test. But then we talk and tell us what were the results. This is important. So I'm going to say the assumption of normality was violated in this particular example. And I say the Shapiro-Wilk test, and I just put the sig values for the male was 0.027, and for the females, it was 0.001. Remember, we have two groups, a male and a female. So we're reporting if that GPA was normal in each group. And so that's why I just say, therefore, judge the results with caution. And that's all that you need to say at this point. Then what happened with outliers? We say there were no outliers, as evidenced by the box plot. Remember, we'll have a box plot in there. And then we'll say what happened with the variances, and we'll say it was not violated. Remember, it would have to be less than 0.05 to be a significant deviation from equality. So as you can understand, all we've done here is just repeated the purpose of the test, restated what the variables were. We restated and let the reader know that we know that there are assumptions that we have to assess. We've assessed them, and this is the result of the assumption test. Now I'm going to report the findings. To answer that research question, remember what we are trying to do is to come to the answer right here. Is there a statistically significant difference? And what we're trying to do is say, do we make the decision to accept this or reject this? So if this is true, that there is no significant difference, we accept this one, we reject this baby here, okay? But if there is a difference, then what we're doing is rejecting the fact that there is no difference, but accepting the fact that there is a difference. And that's a quick lesson on the hypotheses. And this goes for whatever statistical test you'll be doing, okay? And this is what we're looking for. Do we accept or reject this one? Okay? That's what research is all about. And it all boils down to looking at this and saying, it was significant. Yes. So what we do is it was significant. Remember now it's a t-test. So we put the T from last night. Anyone like to give me an example of what the 59 stands for? Same thing it did last night. Remember, now that's going to come from the degrees of freedom. Okay, oops, I'm sorry about that. From the degrees of freedom, and that degrees of freedom are right here. Remember, it was 59. and it's going to come from your independent samples test. There's a 59, okay? What does that 59 represent? Exactly, the n minus 1, which is the sample size minus 1. So this was a sample size of 60. So again, remember now we already know from this write-up that we had a t-test, sample size of 60, and then we have to report the calculated t-statistics. You're not worried about that, but anyway, and then we reported it was negative 2.125. And that's what we have in the write-up, negative 2.125. We report the p-value, 0.038. And as you can see right here in the write-up, the p-value was 0.038, the two-sided. Okay? And remember, we now know, what that means. Now, then we always report the effect size. Okay, and when we talk about meaningfulness, these are the things that we want to talk about, the effect size, and in this case, Cohen's d. Now, with the p-value, as I mentioned last night, most people, we get into a hoopla and think we've accomplished something and found something out when we get that significant p-value. But really, that's just a probability value based on a lot of mathematics. And it's really just giving us an indication of the amount of sampling error that may be there. We've got a significant result, and the odds of it being, at 2.125, blah, blah, blah type thing. But that tells you nothing about your variables, nothing about the meaningness of your research. Meaningness is to talk about the variables. What does that mean? So now we know there's a significant difference here, but what gives it meaning is the size of the difference. And that's the one thing we always want to put in our research and our writings is the effect size, the magnitude of the difference. Now, as you can see, a magnitude of 0.32 is completely different than a magnitude of 0.85, a much larger effect. So it gives us some understanding now of the meaningfulness. And what I want to point you to is the word right here, comment on the meaningfulness. Okay, does everybody see that? The meaningfulness. And another piece of information that gives you meaning is the confidence intervals. And again, that's what I try to put in these exemplars. So you're going to talk about the Cohen's d, but then the mean difference, and we stated what that was. But remember now, the 95% confidence interval. This was one research effort. We clicked the button one time, one sample. We came up with these means, but we know if we did another sample out the same population, we'll get something different. It may be close, and if we continue to sample and sample, we'll get something different. But what this means is that if we did this test 100 times, that we know that 95 out of 100 times, we are sure, pretty confident that the mean difference is between, on the lower end, right here, and to the upper limit, okay? Now, because again, that's a negative number. That's why it looks like that maybe. So again, this has some meaning. Now, what's a wide confidence interval under one situation may be different than under another situation. So again, if you're doing this for your application, remember, you're kind of making up something here. But again, when we talk about meaningfulness, again, the most meaningless piece of information out of this is the p-value. What's important is how large was that effect, that difference? How large was that relationship, in terms of GPA points? So that's 0.32 of one standard deviation is what that means, okay? So the average score, and you always report the standard deviation. So, so you say males, the average 3.56 to standard deviation, reporting lower than females, blah, blah, blah. But what I wanted to show you next here was the actual exemplar that you'll have, okay? And again, let me try to make this bigger for you. And as you can see, you remember from the other two that we've got, this is just the independent samples t-test, blah, blah, blah. And read this very carefully because it gives you some information on how this was put together. It talks about there's footnotes, that'll help you help you understand some of the concepts. You'll see footnote down here, etc. Wherever you see, the footnote indication. And again, additional resources can be found here. This is the YouTube site that you'll go to get the recording sometime tomorrow or whenever you need it because it's on demand. Now, again, as you can see, here's just a research question, stated the same hypotheses, and then in your application, they want you to show some knowledge and understanding of what you're doing. So I just put a discussion here where you made a statement where you understand, what the test is used for, provide a citation. But here, notice in the footnote, I'll say, provide evidence as required. So that's not up to me. But then, as you can see, the results will be here. And this is exactly what we just looked at in slide format, okay? And I'm telling you here in this case, that there was one outlier, but I kept it in the analysis. I'm showing you what I did with the box plot. But then again, you have to provide your output. And so again, here's the box plot. You see, and this is the case here, that one outlier would be case number 46, if you can see that. Okay, but I said that I kept it in the analysis. And again, you can see it's showing the males and the females, no outliers in the female category, but one outlier. That's not really bad. And then I'll tell you that there's a descriptive statistics table, and here I have the descriptive statistics by gender, where the average, and you can have a descriptive statistics showing how many were male, how many were female, etc. But what you're going to be requested to do is to cut and paste, the output. And what I put here is a little table to help you. Make sure that you have a box plot. Okay, here's a box plot. And then appendix, the last page. The Shapiro-Wilk test of normality. Here it is right here. Remember, we're going to be looking over here in the far right. So males, as you can see, and females were both less than 0.05. And that's what we stated in the write-up that, we violated the test of normality. And so we just made a statement, judge the results with caution, okay? And then the output then says, make sure you have a group statistics. This shows the means and the standard deviation. Remember, this is the t-test results that we just looked at. Remember, to the left here is the test for variances, and then to the right is the information that we put into our write-up. And then the effect size is Cohen's D, which is right here, okay? And so that's what you want to, and this should help you. So as you can see, all of this in here should correspond in your write-up, should correspond with what you have here in your SPSS output. Now, does this make sense now in terms of, what you're trying to do, what the application is asking you to do? Now, I'm not asking you, can you go and repeat this right now, and do it, but do you kind of understand now as you look at the output here, what we just discussed, and now go back and let's do that. Now let's go back and let's look at the scenario now. So now from this scenario, do we truly understand the scenario now a little bit better in regards to what it is that we are trying to do in terms of an independent samples t-test now? And hopefully it reads a whole lot differently now than it did maybe, 45 minutes ago. And that's the piece that I'm talking about that we're trying to get to right here, okay? And I'm seeing, some of the comments, it's a little bit better understood, things of that nature. This is what we're trying to do, get this face right now. Now, 30 minutes from now, when we hang up, you may be back over here, I don't know. But again, I see, Victoria, you said it made more sense now. And that's what we're saying. When it makes more sense, the anxiety goes down. And this is what I'm trying to do here, okay? And you'll always have the recording to go back and back over again. because again, I can't, just pound it in your head. You'll always have it, okay? You'll always have it, okay? So now, again, now before what we'll do now is to make sure I don't forget. Now I'm getting ready to take these documents and put them into the chat for you. So the first one that I'm going to load up in there is going to be the exemplar. So check in the bottom of the chat now and make sure that you see the independent samples t-test exemplar. It should be the last document in the bottom of the chat, okay? First person see it, can you type yes or something? I want to make sure you have that, okay? Then the second one that I am going to put in there will be the presentation. But again, it'll all be, and we'll look at the YouTube page here. Which one will this be? Yeah. And now the second one should be the presentation, okay? Now, of course, it's not yet on Zoom. We haven't finished it yet. This will be recorded. Again, the process is this is being lively recorded. And it takes a while to process after this. I have to upload it and go through things. So it'll take a good day sometime tomorrow. But for those individuals that did the paired sample last night, if you go out to the site, you'll see that that video tutorial is out there, okay? So now, please remember, resources and survey, remember, you can always go out here to this link where all the links to the recordings will be also. And then also, again, the survey is going to be very, very critical to be needed. Okay, so again, when you get the presentation, just simply click on this link and this will take you to the survey, okay? I'm seeing that some individuals want me to put the survey in the chat, but again, you'll always have access to this. Remember, these are going to be on-demand resources that you have so that you can get to this stuff at any time you need it. So that's in the chat now. That should be the link in the chat, hopefully. Okay. Now, so again, I thank you for your attendance. What we've done here in the past 3 weeks, for those of you particularly who are taking the research course, you'll be coming up on the t-test. We've had a very brief overview of the 3 types of t-tests. The one sample t-test we looked at, then we looked at the repeated measures, and then we looked at the independent samples, each one of those aligning with the 3 scenarios that you'll be addressing in that weekly application. Now, the other thing that I just want to show you real quickly before we sign off here, because we're right at the top of the hour, is the YouTube. Now that link will take you out here to this page, and as you can see, that last night's session of repeated measures t-test is here, okay? Again, the one sample t-test is here. The week before that, we did confidence intervals, descriptive statistics, the visual displays of data when you first started in the term. So again, if you go through all of these, at the time needed, you'll see that there'll be a lot of helpful information. So if you have to discuss descriptive statistics or something in your journey, perhaps clicking right here on the descriptive statistics webinar, will be of help to you. But again, what you'll see here tomorrow will be the independent samples t-test will be added to this list. I don't want to play anything. But anyway, so I just wanted to share that with you. And again, I ask that you take the opportunity to go out to the survey and complete that survey. Let me know what we can do better, what you need more of, or if this is helpful to you, whatever. Because this is basically morphed out of absolutely nothing. And I tried it out one night and got a lot of feedback and did a little bit more, and it's morphed into what we're doing now. So anyway, I thank you for attending. I don't have a schedule for upcoming seminars because I haven't planned it yet, but more than likely, The week following the t-test, we then move into the one-way ANOVA. And that's the next logical progression. You remember when we looked at SPSS and we saw the 4 groups in that region variable? For example, we were here in the country and we had the 4 groups. Well, suppose we're trying to compare all 4 groups, or suppose we have to compare 3 groups. Well, the t-test won't let us do that. The one-way ANOVA becomes the next logical extension because it allows us to compare more than 2 groups. So that's just kind of give you a look for it so you can understand logically that we're progressing through different scenarios so that you can say, well, I have this amount of groups, this would be the right test. Or I have this scale of measurement, this would be the right test. So hopefully that's you get an understanding of that, and we'll continue, in this vein here, to really try to get you to understand, and hopefully you can see the relationship now between this data set that you're looking at. And I think that's important. The data set that we're looking at right now, we're in data view. I'm in data view, and I'm now in variable view. But do we understand that in the context of what we're being asked? That's the important thing. There's always a correlation between this scenario and what's in that data set. And I'm trying to bridge that correlation for you so that when you see something like this, you're able to go into a data set and kind of understand what you're trying to do. Does that make sense? And so we kind of put the 2 together, okay?
Dr. Taylor, the exemplar did not post to the chat. Is there any way you could redo that for us?
I can put it in there again. If it's not there, I don't know what the issue would be. Has anyone not received it, or some getting it, or what?
Not on Zoom. For those of us on Zoom, we can get it.
Everybody's on Zoom. I'm saying, has anyone not seen any of the documents in the chat? No one? Okay, let's try it again. Okay. All right, let's see. It's an exemplar. Okay, I think I know what it may be. I know what's going on. And you see, someone sent a chat, but it was directed to me and not to everyone. And I responded back to that. And so it just went back to that individual. So that's what happened. So now let me put the other one in there. Okay, now everyone check and see in the bottom should be 2 documents, and everyone should have access to that now. Okay.
Got it. Thank you, Dr. Taylor.
All righty, fantastic. Okay, as you know, we like to keep it within the hour. We don't want to absorb too much of our brain power, but hopefully, if we were doing what we did last night, the repeated measures t-test, okay? And if we were to measure our anxiety or our understanding of the independent samples t-test, say on a scale of 1 to 10, like we did last night, before and after, do you think that we would get a significant finding, that we would get a significant increase in our confidence or knowledge of the test? Do you think you would, or we would? Do you feel, would you respond on a higher number on the second measurement, on the repeated measure, I guess is what I'm asking?
Well, yes.
Yes, fantastic. Okay. So as you can see, again, this is an example of how a repeated measures t-test could be done. I could have said when we signed in, hey, everyone, give me your initial level of on 1 to 10 of your knowledge of the independent samples t-test. Within an hour, we do that. I get the same number. And remember, I have to match you. And then we run the test to see, did we get a significant increase in whatever we were measuring? And that's just these things are not that demystifying. Just once we kind of understand, what these things are. Now, remember, as we start reading journal articles now, and we've been asked to critically synthesize research, Now we're able to start critically synthesizing. Until we get to kind of understanding this stuff, we really just read an article and we regurgitate back what we read. Oh, I read this article and the purpose of this study was to do this. The research question was to do this and blah, blah, blah. But then when we get to findings, we put it down because we have no idea of how to take that information and interpret it. And that's what we're hoping that we're getting to now, where we can look at those results in those studies and interpret it so that when we see, something, in a journal article that looks, like this, we now know, what we're looking at. You see what I'm saying? That we now have some indication of what we're looking at and some indication of what this stuff means. That's what we want to get to. The SPSS piece to me is my least worry, clicking the buttons, because we really need to understand, what we're doing and how all of this, just think about it, if you're doing a quantitative study, you're going to go months and months or whatever term and writing literature reviews and this and that. And all it's going to come down to is you doing this. Analyze, compare means, independent samples, t-tests, you put the data in there, bingo, and there's your data analysis right there in less than 30 seconds. Versus if you go qualitative, you could be months trying to collect data. But anyway, I want you to understand what you're looking at. Hopefully this has been helpful. Be on the lookout for the announcement coming for the one-way ANOVA or whatever other ones that may be put into play here to help you out, okay? So again, I thank you for your time. Have a great evening. I'm going to keep the class open a few minutes so that you can get the documents out. But again, I hope this has been very helpful and that you feel a lot better now about the 3 t-tests than you may have this time last week. Okay? That's my wishes.